All right, today we are going to do some mole conversions. So I'm going to go through several practice problems for you after we review some info. So first thing, let's review Avogadro's number. Tells us there are blank atoms in every 1 mole. 6.02 times 10 to the 23rd atoms. That's a huge number, but remember atoms are really tiny. The unit we measure mass is in grams. We measure the amount of a substance in moles. The units for molar mass are grams per mole. So what is the molar mass of carbon? If you look at your periodic table, you'll see 12 grams per mole. We don't need that E. What about for water? Here we have to add up a couple things. So for water, if we add it up, each hydrogen is 1 plus oxygen, 18 grams per mole. All right, let's get to these practice problems. So first we'll do mole conversions from moles to grams. Okay, how many grams are found in 5 moles of beryllium? So we will always start with the given information on the left, and I've tried to organize this in a way that will help you. So I'm going to write 5 MOL, 5 moles of beryllium. We could even put Be if you want. Next, we want to put units that we start with go back down. So that's going to be moles of beryllium. Units I want. So what is the question asking for? It's asking for grams. So I'm going to put grams of beryllium on top. And so then we have to put numbers here and here. So what number should we put? Well, how many grams are in 1 mole of beryllium? We look at the periodic table and we see that there are 9 grams for every 1 mole of beryllium. So how do we do these calculations? Well, you simply multiply top 2 numbers and divide by this bottom number, 1. So 5 times 9 equals 45 grams of beryllium. Make sure you include the units, in this case, grams. So what happened to the moles? Well, the moles get canceled out. Units on top get canceled out with the units on the bottom. Okay. Basically, we're taking a number and we're multiplying it by something like this. Okay. So anytime we do moles to grams, the key thing here is we multiply by the molar mass. Okay, so multiply. What if we wanted to go from grams to moles? So here we're still looking at beryllium. And so how many moles are in 81 grams of beryllium? So we always start with the given information. We've got 81 grams of beryllium. The units we start with go back on the bottom. So if I started with grams, I'm going to put grams back down here. It's asking for what units? What are we looking for? We're looking for moles of beryllium. So here, for every 1 mole of beryllium, how many grams? Well, we can see here on the periodic table, there are 9 grams for every 1 mole. So here, grams of beryllium cancel out. And instead of, so we do 81 times 1 divided by 9. So really 81 divided by 9. That's going to give me 9. And then the units I have left are moles of beryllium. Okay. So anytime you're doing grams to moles, here we divide by the molar mass. Okay. Next, what if we have a compound? How many grams are found in 3 moles of carbon dioxide? So always start with the given information. 3 moles of CO2 here. And it's asking for grams. How many grams? So I'm going to put grams of CO2 on top. Units I start with, moles of carbon dioxide. Those are going to go back on the bottom. It's always going to be a 1 next to moles. So for every 1 mole, how many grams of carbon dioxide? So we have to go through another extra step here and add up all of these atoms. So 1 carbon is 12, plus I have 2 oxygens. Each one has a mass of 16. 12 plus 32 is going to be 44 grams per mole. Notice that's exactly what we're putting into here. 44 grams for every 1 mole of carbon dioxide. Okay, to do the math, we simply multiply 3 times 44, and we get a final answer here of 132. These units cancel out, and we're left with grams of carbon dioxide. Okay, so again, whenever you do moles to grams, we're just multiplying by the molar mass. If you have to do the extra step, finding the molar mass of your compound, make sure you do that extra step here as well. All right, next example, we are looking at moles to atoms. So atoms are different than grams. Remember, so the question is, how many atoms are found in 2 moles of carbon? Remember that 1 mole is 6.02 times 10 to the 23 atoms. So always start with what we're given, in this case 2 moles of carbon. We're looking for how many atoms. So I'm going to put atoms up here, and you should just start remembering this number, Avogadro's number. So there are that many atoms for every 1 mole. Remember, units that we start with go back on the bottom. So if I started with moles, I'm going to put the moles back down here. And then our final answer should be in the units we want, atoms. All we have to do here is multiply these 2 numbers. Oops. And we get 1.2 times 10 to the 24th atoms. Okay? So again, I just multiplied those 2 numbers. So anytime you do moles to atoms, we're going to multiply, again, moles to atoms, multiply by Avogadro's number. And remember that's 6.02 times 10 to the 23rd. Okay, anytime you do moles to atoms, you're multiplying by Avogadro's number. Okay, one last example here. What if we are trying to go from atoms, in this case, how many moles are found in this many atoms of silver? Here we're going from atoms to moles. So I'm going to take that 7.5. Again, include units. And then I want to get moles. I'm going to put moles on top here. And I'm going to put atoms on the bottom. For every 1 mole, I know that there are 6.02 times 10 to the 23 atoms. Okay, so mathematically, our atoms will cancel out. We're going to divide by Avogadro's number here. So if you do the math on this is why you need a scientific calculator as well. We will get 1.2, we'll just leave it at that, 1.2 moles of silver. Okay, so here, when we're going from atoms or molecules to moles, I'm just going to divide by Avogadro's number. All right, so make sure you refer to these examples to help you with the worksheet, and we'll continue to